Hey guys, let's stand by for a couple of minutes and then we're gonna start.
I have a quick question before we begin.
Yep, what's up?
Is control flow integrity that Intel is providing? I know we talked about this a long time ago, but I was just wondering how you think that control flow integrity would affect ROP.
It's gonna affect Rob very badly, honestly, because right now, you have to, you have to find the correct match in order to match with the byte that in the control flow integrity. If we're talking about the what is, I forgot the name of the instruction, but if you disassemble it, you will be able to see that you will be able to see that from the, like, it's the first instruction of the function, right? So that means that right now, if we're going to use wrap chain, you have to find the wrap chain that contains the correct prefix, which is going to be hard. So yeah, I do think that the new implementation in Intel will stop a lot of wrap related attacks.
And are you teaching any classes next semester?
Yes, I am teaching. I am teaching undergrad level introduction security next semester. All right, guys, and then now we are about the time to start. I'm pretty sure that you already see my screen and my slides. We can start. Give me a second. Let me just turn on chat so that I can take a look while we are talking. Oh yeah. Thanks, Kyle. Yes, it's NBR, and then the end of branching, and then I forgot what's the first one. Is that called star or anything? The one that I think there are two, like it's in a pair, but I forgot the name. I think one is called NBR64, and the other I forget. Anyway, guys, let's start. So again, welcome back. I know I already talked to many of you in the last hour. We have a wonderful Q&A in the office hour. So you guys know that our third assignment is going to be due very soon. It's going to be the end of this month in 2 days. So we are going to probably stop the service. Well, actually, we're not going to stop the service, but we're going to cache the score. And you will still have some time to work on those challenges, especially that, if you want to take advantage of your grace period, you can use that and you can just keep going. And then we're going to just cache the scores every day. And then we're going to use the cache the scores for those that requires grace period. So make sure that you want to get a good score from assignment 3, and also make sure that you don't have to get the bonus score. I think there are 2 challenges there specifically. Well, actually, yeah, 2 challenges that are more challenging, they're more difficult. One is the 7th challenge from baby format, and the other is the 10th challenge from baby stack. So if you are getting stuck on these 2 challenges, my suggestion for you is just to move on and then focus on the other challenge first. Also, for baby stack challenge number 4, if you are getting stuck on that, I will also recommend you to move on and look at 5, 6, 7, 8, those ladder challenges at this part, because challenge 4 is level 4 is more difficult than like challenges from level 5, 6, 7, 8. I would say that. So make sure that you manage your time wisely so that you can get a good score for assignment 3. Also, guys, you may already noticed that I don't have too much videos posted this week. And also, I won't have too much video to post the next week. I will probably still like post 2 to 3 videos because I want to give you less load because of election. Make sure that you take advantage of this time. You can take a break. You can review what you have, or just go out and fulfill your election obligation, responsibility. It's gonna up to you, but I highly encourage you to take advantage this time. All right, this is all about announcement. Do you guys have any questions?
Professor, which one are the bonus challenges?
So there are 2 bonus challenges. One is from baby format level 7, the last one, and the other is from baby stack and level 10.
Sure, thank you.
Yep. And then for baby stack level 10, you need to learn a specific attack by yourself, which is called seed return rob, or you can just use that as, or you can call it ASROB for short. And you could just like Google it. There are a lot of documents talking. I think there is even a Wikipedia page about ASRock, which will give you a very nice high-level picture of how it works. Also, for ASRock, there is a pawn-lib function. Oh, there's not one, but like there's a bunch of pawn-lib functions that support ASRock. You probably want to take advantage of that too, because you need to really construct the stack, many content, but you need to construct it in the correct way so that those content on stack will be reflected to registers. So you really want to use pawnlib, which will definitely help you when you construct the layout of the stack. Okay, so guys, now we're gonna kick off for our class in class lab. And the server has been on. It is in the port of 9999 because this is going to be our week 9. And the binary in the source is also available in the course website. Now it's going to be your turn to play with the challenge. And I'm hoping that some of you will be able to nail down this challenge without my instructions. Also, guys, the library that we're going to use is the same as last week, which is still libc 2.27. So if you don't have a native 2.27 libc, you can download libc from last week's links. It's the same. And then if you look at your course website, you will be able to, like the schedule page, you will be able to get libc with the version of 2.27 in week 8.
can you let me know if it was inputted correctly in the system, in the server?
Oh, the server's down? Let me check.
No. I mean, I submitted my.
Oh, you mean your log? Sure, let me check.
Yes.
Yes, give me a second. Yes, I see your ID. Good job.
Cool. Thank you.
And besides Alan, we have another of us who also solved the problem. Good job.
Was that person me?
Yes.
Okay.
Yeah, I was a little bit hesitant if I should de-anonymize that person, although it's a good thing, but still, I'm a little concerned. That's why I didn't say your name. But yeah, it is Soham who also solved this problem. Good job, guys. We have 2 more students solve the challenge. That's amazing. All right, guys, I'm gonna give you 2 more minutes, and after that, I will give you some hints. And for this time, after I give you hints, you will still have time to work on the challenge by yourself. All right, guys, let's start. Let me share my screen with you first. I am using my virtual machine, so now you should be able to see the screen of a Ubuntu machine. It's the Terminator on my program. Okay, so first of all, I believe that you guys also have the source code. The source code is also online, but let's just try to work on this from the source code level. Sorry, from the binary level. So I am going to do Ghidra. If I don't have the shortcut, let me go find my shortcut. Or actually, let me just use my IDA. So if you look at IDA, first of all, IDA doesn't have a source code. I don't have a disassembler, a decompiler over here. So you will still look at the disassembly, but that's okay, because we know most of the code. All we need to know is that, first, if there is a win function, and turns out, yes, there is a win function, right? And then the next step we need to make sure is that where are we going to put those message, and then what message that we can put. So if we just browse it around, we found there's some -ds over there, and it has like pointer cannot be edited. Okay, so now let's try to run it. I'm gonna just close it. Not too much information, but still we know that we have a win function that we can use. Actually, give me a second. I think I go to the wrong place, although this code is the same. I'm gonna use this one because this one is exactly what you have on your site. Okay, so now let's take a look at the source code and run it. I'm gonna run it over here. So this is very similar from what we had from last week. It's gonna ask you, what do you wanna select from the menu? And you can decide to allocate a chunk, free a chunk, added it or just list all the pointers. So the difference, the difference between this code and the last week's is that if you look at act added, you will find that there is a condition that is put over here. So in this condition, it says that if you want to add a pointer, it's going to check if the pointer is still underused. And then if the pointer is freed already, we're going to return. So we're not going to do the rest of the stuff is the chunk has been freed. So in this case, there's no use after free vulnerability specifically. However, there is a double free vulnerability. And if you have checked the video of a double free, you will be able to know how double free works. And on the high level, the way that works is actually pretty simple. It's just that you want to have two chunks. You want to have one chunk, but you want to free it for twice. In this case, if you freed it for twice, the first time that you use it back, like you use malloc to get it back again, there is one chunk that is going to be both under use and in the free list, in the Tcache beans list. In this case, then you will be able to add the chunk because you already have, malloc, you have that chunk. But also because the chunk is still remains living in the Tcache bin, when you added it, you'll be able to add it to the metadata that stores in the Tcache bins. So in this case, if you added it, it's going to be very similar to use after free. Once you just free the chunk for twice and then use malloc to call it back to use it for, to get another pointer that points to the same chunk. Okay, so now let's gonna work on the attack together. I'm gonna just reuse those utility functions that we have from last week. You also should already have that. So all we need to do is just to remove the part of launch attack. And we're gonna work on this together. I know that some of you just take a screenshot of what I'm showing, but I really hope that at this point, since it's not the end of the class yet, I want you to, after I list those steps, I hope that you can just write this code by yourself using those utility functions to fulfill those steps. So at this stage, I'm gonna hint you by giving you those steps, and then it's gonna be your call to, execute those steps by using the utility function that you had from last time. Okay, so now let's try to understand what we're gonna do. And then meanwhile, I'm gonna close the source code on the left-hand side because I'm gonna use it as a blackboard. Okay, so the first step that we're gonna do is we're gonna free a chunk for twice. But in order to free it, we have to allocate first. So we need to do malloc to chunks. Oh, actually, we have to malloc one chunk. One chunk will be enough. And then we're gonna free the chunk for twice. And at this stage, if we think about the Tcache bin, oh, this color is not good. Let me change to a brighter color. So after we do free chunk for twice, we're gonna have chunk 0 and then 0.2 chunk 0. We're assuming that the first malloc chunk, that is chunk 0. Okay, so after we free the chunk for twice, what we want to do is we want to, use one chunk, right? We probably want to take this out so that we can make this chunk 0 in use. So to do that, we need to do a malloc again. So we want to malloc the chunk with the same size so that we will be able to get chunk 0. And the next is we need to add it chunk. And then similar to last time, we're going to use the malloc as the victim address. So we want to use added chunk and then put victim and put victim object into the chunk. Basically, we want to create a malicious, illusion for Tcache that chunk 0 want to point to the place of the global offset table entry for malloc. And then after that, that means that we already, the current Tcache bin becomes chunk 0 points to global offset table of malloc, right? Because this part is already malloc out. So I'm going to use Fred to crawl this out. It means that it's already malloc to some pointers that are currently in use. So the next is we need to do malloc and malloc for 2 times, because the first time of malloc we'll be able to get chunk 0 again, and then the second time, that's 1. That's first. Let me write it better. And then this is the second time, right? So in this case, in the second time of malloc, we will be able to get the global offset table of malloc. We will be able to get the victim object. And then the next is similar to use after free. We want to edit it. Added the chunk with the value of function win. Added the chunk, replace the value to function win. And then all we need to do is to trigger the malloc by, calling malloc again. I usually just do like interactive here so that I can manually trigger this, because later on you will be asked for the ASU rate. Okay, so that's pretty much it. Those are the 7 steps that you will need to make this attack happen. Now I'm going to give you more time to work on this, and then hopefully you will be able to come up with an attack by yourself.
Sorry, I forgot with editing the allocated chunks content. How does that work again?
I mean, I don't quite get your like. What is your specific question? What do you mean by how malloc work? You want to know how malloc internally work, or you want to know how to call the malloc function in the utility function?
I think just how to call malloc with just with our attack strategy.
You can check the code from last week. You should be able to get how to use malloc from over there.
Oh, okay. All right, my bad. Thank you.
Yep. There is a question from chat asking the purpose of step 2, which is why we're doing free chunk for twice. So the purpose of that is to, generate a false chunk. When I say false, it means that this chunk is not good. This is like a vulnerable chunk that an attacker can take advantage. And especially for this case, this chunk, it has this fast bin, it has two chunks. It's the same chunk. It's going to be both chunk 0. However, these two chunks, they're actually they're considered as two separate chunks in the Tcache bins. So the reason why we want to have something free for twice is because we want to trigger the vulnerability, and then we want to construct a fast bin. We want to construct a Tcache bin with two identical chunks, and then they are kind of linked to each other. And I see 20 people has already solved this problem. That's brilliant. And I am gonna talk about the code, implementing the rest of the code with you guys together in 5 minutes. Answering the question from chat, when the same chunk is located in the same Tcache bin, they will not be considered as both free and allocated simultaneously. And that is exactly why double free is vulnerable. Because when Tcache, look at this list, it will consider these two chunks are different. That's why if we have, like chunk 0 points to chunk 0, and then when we have this part, when we do one time of malloc, this chunk 0 will, get down, will be like separate from the list. If you look at the list, it will only have one chunk 0 at this point, but you will also return a chunk 0 coming from malloc. So this is why in your free list, in your Tcache bin, you will still be able to see chunk 0. And also, right now, by using malloc, you will get a pointer that points to chunk 0, where you can start to add the chunk 0's content. And those questions are nice questions, guys. If you have more questions, I think now is a good time to ask. The reason why we need 2 mallocs on step 5 is because once we added the chunk 0, added that to, link to the got table, we need to get this part. We need to get this victim place so that we can overwrite, right? That's why we need to, in order to get this part, the global offset table of malloc, we need to use malloc to get it. And if we do malloc for one time, then we will get chunk 0. And then after we do malloc for second time, we will get this part, which is the global offset table of malloc. All right, guys, now we are going to write the program together. And before I write the program, I just want to say that right now we already have 30+ students solve this challenge by themselves. I'm very impressed, and good job, guys. Cool. And then for those that cannot solve it, that's totally fine. This is why we have a class. So now we're going to work on this together. I'm pretty sure that after we work on this together, you'll be able to solve it by yourself. Now I'm going to clear this just in case that we need it. I'm going to clear the Blackboard, and we're going to work on this together. Okay, so the first is we're going to malloc, just as what is that, malloc, right? So we're going to malloc one chunk, and then we want to free the chunk for twice. So we want to do free, and then we know that the first one, it has the index of 0. So we'll do that twice. And then the third is we want to malloc a chunk with the same size so that we will be able to get one of the freed chunk, which although it's the same, but like if you look at the key cache bin, you'll see 2 chunks over there. So now let's gonna get one. And remember that the index should be 1. So the first step is to edit the chunk and then put up victim object into the chunk. So we need to edit it. And then we need to edit the chunk with index of 1. And the content I want to put is the location of the entry of malloc in global offset table. And make sure that you wrap it up with P64, make it little endian. And then I'm going to put malloc. Cool. After that, 2 times malloc, no problem. And this time, is gonna be index with 2. Malloc again, index 3. And now we know that this is gonna be the victim. After that, let's change this victim with the value of function win. Again, wrap it up with P64 with E dot symbols. Symbols dot win. Okay, and right now I am gonna stop and I am gonna run this attack with the GDB together so that you will have a better idea of what it's doing over here. I know that this is a little bit abstract, so that's why I want to run the GDB with this together for you to have a better understanding. And okay, so I am going to do now we're at function main. And then let's set the breakpoint. I'm going to show the code over here. Let's just set the breakpoint somewhere, say here, like after we read the buffer. Check the number, it is 108. I'm going to do 108. Let's continue. Okay. And if you check the buff right now, you got M8, right? That is the correct message saying that you need to malloc. And then if you look at the heap, there's no heap yet because we haven't allocated anything. Now let's continue. So now we have one chunk. Continue again. Now we have still one chunk, but here we see that this chunk goes into tcache bins. If you look at tcache bins using bins command, you will be able to get tcache bins with the address. And then now let's continue. If you look at bins again, so we see that there are 2 items in tcache bins, and both of them are this like hex 12C8260. And if you look at the attack code, I'm going to open it anyway. So we should already at this place, right? So we have this time of free already. That's why we have 2 identical chunks linked to each other in tcache bins. And then next, we're going to do a malloc. All right, after that, let's take a look. Actually, let's take a look at bins. So it still considers that we have 2 bins. However, if we continue and take a bin again, we found that right now, because we're editing the bin, we're editing the value from this place. And let's take a look at the heap. So we change that value to this value, which is the entry of global offset table. That's why when you look at bins again, the tcache bin will consider that currently this address is pointing to the global offset table. And remember that right now there are 2 items over here. So that's why we need to do 2 times of malloc. Continue, take a look at bins again. 1 item left, and then continue, take a bins again. There's no such bins because we already got all those chunks from the freed tcache bin. Cool. And then now let's continue again. It says it's over because after added, we don't have anything more. No, let's exit this as well. And let's go back to what we wrote over here. So here we already finished those. And then what we need to do is to do interactive. And then let's try to run the attack. It says right now it switches to interactive mode. And then let's try to malloc. Now we go to the winning function. It asks you your ASU right. Okay, now we get the entire code. You can put whatever. I'm gonna put my handle and then we're done. Yep, that's pretty much it. Any questions? Oh, for symbols, I mean, both works. You can use e.symbols.win or e.symbols as a dictionary and then win. All right, guys, that's pretty much it for today. If you don't have any questions, I'm gonna stop sharing and then we're gonna call it a day. Also, I'm gonna stop recording